There are two pharmaceutical evidence samples were investigated in this study, namely paracetamol and aspirin. These drugs were selected because they are commonly encountered pharmaceutical evidence and are frequently involved in toxicological investigation and misuse cases. The objective of this study was to analyze and interpret pharmaceutical evidence using multiple analytical techniques.
For paracetamol, the maximum absorption wavelength was observed at 236 nanometer with an R-square value of 0.9929, indicating excellent calibration linearity. The unknown concentration was calculated as 76.90 mg per liter. Since the R-square value is very close to 1, this suggests a very strong relationship between absorbance and the concentration, supporting a reliable quantitative determination. For aspirin, the maximum absorption wavelength was observed at 276 nanometer with an R-square value of 0.9833. The unknown concentration was determined at 51.04 mg per liter. Although slightly lower than the paracetamol, the R-square values still demonstrate acceptable calibration performance and support successful quantitative analysis. The SEM image of paracetamol showed plate-like particles with layered crystal arrangement. At higher magnification, fine cracks and small adhered particles become visible. However, the crystal surface remained relatively intact. The absence of abnormal structure features suggests that the sample maintained its expected morphology without obvious physical changes. In contrast, the aspirin samples show rounded clustered particles with irregular particle arrangement. At higher magnification, smooth particle surface and small fragments were observed between particles. Compared with paracetamol, these characteristics suggest structural changes and have different particle morphology.
The GC-NS chromatogram from paracetamol saw a relatively simple chemical profile with paracetamol represent approximately 99.65% of the total detected composition. Only trace impurities such as diacetamide was identified in very small quantity. Since only minimal secondary compounds were detected, this finding indicates that the sample remained chemically stable and maintained high purity. This also supports the UV and SEM finding, which show normal concentration behavior and in particle morphology. In contrast, the aspirin chromatogram saw a considerably more complex chemical profile. Only an aspirin was detected, while several secondary compounds including phenol, methylsalicylate, and phenol acetate were identified. Compared with the presence of multiple detected compounds substantial compositional changes within the sample. The finding also agree with SEM observation which show altered particle morphology. Therefore, the GC-NS result provide important evidence for distinguishing the chemical character of both pharmaceutical samples.
Each analytical techniques contributed different information regarding the evidence samples. UV visible spectroscopy provided concentration information, SEM provided structural characterization, and GC-MS confirmed chemical composition of detected compounds. Combining multiple analytical techniques increases confidence in forensic investigation because a single technique alone may not provide sufficient information. Therefore, using multiple methods reduces the possibility of evidence misidentification. Overall, the analytical findings successfully differentiated paracetamol as a chemically stable sample and aspirin as a structurally altered sample.